Hello again. So right now we will be solving another VSDE type of differential equation, but we will be solving for the particular solution. Why? Because we are given the initial conditions of the problem, then we can solve for the particular solution. We can solve for the exact value of the arbitrary constant. And since initial conditions are given, this is what we call an initial value problem. So, first step, observe the differential equation and determine the type of differential equation. And since we are just discussing a variable separable type, then we are sure that this is a variable separable differential equation. And what is the goal for a VSDE type? We have to put all the x beside dx and all the y beside dy. But as you can observe, there is a 2y here. So what are we going to do so that we can modify this form into a VSDE? Okay, so first step, so we can actually modify the form of that differential equation into this. So algebra, guys. Okay. E to the x. This e to the x plus 2y, we can make that into this form. E to the x times e to the 2y. You get that? Minus e to the negative y dy equals 0. And to put this beside dy, we'll just divide both sides by e to the 2y. We divide everything. By e to the 2y. Now what happens? It would become e to the x dx minus e to the negative y all over e to the 2y dy. And of course, 0 divided by anything, that is 0. Simplify the equation. This would become e to the x. Can you clearly see my penmanship? Okay, loss of exponents, e to the negative y all over e to the 2y. That would become e to the negative y minus 2y. And that would become e to the negative 3y. Oh, you have to recall your algebra. So now look at this. All the x expressions that contains x are put beside dx, and all the expressions that contains, or the terms that contains y, are put beside dy. So now we have a variable separable type of differential equation, and to solve for the solution, for the general solution first, just do a direct integration on all parts. The bitok. So integral of e to the x dx, that would be e to the x, simply e to the x. Okay, minus. Now, how to get the integral of e to the negative 3y dy? Can you still recall? So, let's first erase that. We'll solve this first. Okay, the goal of this one is not really to solve this manually, but I just want you to review your integral calculus. Maybe you have forgotten. So for this one, e to the negative 3y dy. What to do? Okay, so let u, I don't know if you still remember this, let u be equal to negative 3y, and du would become negative 3 dy, such that our dy would be equal to negative 1/3 du. Oh, negative 1/3 du. So this negative 1/3 is our neutralizing factor. So let us substitute these y's into u's. Okay, I will continue in this part. Just wait for a while. Okay. So that would become, from this equation, I'm going to solve this one, huh? The answer for this is what? A while ago we have written that that is e to the x, simply e to the x. And for this one, I will rewrite that into this form, minus negative, there is a negative neutralizing factor that is negative 1/3. So that would be negative 1/3 times the integral of e to the, what is our negative 3y? Okay, so that is u. So that would become integral of eu. And what is our dy? That is negative 1/3 du. So the negative 1/3, I put it here. And that would become du. So this means that this expression, integral of e to the negative 3y dy, is just simply this one. eu times negative 1/3 du. E to the y times dy. Or e to the negative 3y dy. Okay, is equal to integral of 0. Let's put that as c. So what happens? This becomes e to the x, negative, negative, that becomes 1/3. Okay. Integral of eu du, that is simply eu, right? But what is our u? Our u is, go back to this substitution method, negative 3y plus, equals c. Simply, so now we have gotten the solution or general solution for this one. Let us just simplify the equation. Multiply both sides by 3. This becomes 3e to the x plus e to the negative 3y. Wait. 3c. Again, 3c, c squared, e to the c, ln c. That is just simply another arbitrary constant c. So this is our general equation or general solution for this differential equation. Now, the problem is asking for the particular solution. So what we are going to do is that we are going to substitute the initial conditions to our general solution. I'll just put that one here so that you will be reminded. Substitute initial conditions to the general solution. Don't you ever forget that. Okay. Let's proceed. Substituting the general or the initial conditions. What is the initial condition? When x equals 0, go back to the problem at the top. When x equals 0, y equals 0. Okay. So substitute that to the general solution when x equals 0, y equals 0. So that would become, ano? X equals 0, y equals 0. So that would become 3e to the 0 plus e to the negative 3 times 0. Okay, that's simply 0 equals c. And what is e to the 0? Okay, recall any number raised to 0 is equal to 1. This is 1. So 3 plus 1 equals 3 in 1. Joke. C equals 4. Now, to solve for the particular solution, guys, I hope you can really see my penmanship because I think it's too small. Just comment down below if you want a bigger handwriting. Okay. So the next step to get for the particular solution, simply substitute the value of your arbitrary constant to your general solution. So we have here our particular solution would be particular. Uy, may orange. Says particular. Oh. No, it was. Okay, particular solution. Particular solution, that would be ito, 3e to the x plus e to the negative 3y is equal to, what is the value of our arbitrary constant? That is 4. Okay. So now we have a specific value for our arbitrary constant that makes our solution the particular solution to the differential equation. So that's it. If you have suggestions or you want to correct me, then just comment down below. Thank you.